Hello everyone, welcome back to the channel. It's Fraser, of course. In this video I'll be doing question 15 of the 2011 Senior Maths Challenge paper. I'll just get straight into it. I hope you enjoy it. So the question states, the equation x squared plus ax plus b equals 0, where a and b are different, has solutions of x equals a and x equals b. How many such equations are there? Right, well let's have a look. First things first, we need to have the equation out again. This is the same as a second ago. But importantly, in order for this to be equal to 0, it needs to factorise into two. One of its factors needs to be equal to 0. Therefore, it would need to factorise into x minus a times x minus b, because in a regular quadratic, which of course this is, one of these would be 0. Either this would be 0 or this would be 0. Whoops. Yeah, there we go. Now, does that mean we have two solutions? No, it doesn't, because it says how many different equations, which is how many values of a and b do you have for this equation, not how many solutions does each one of those equations actually have. Otherwise it would be a very easy question. Now, what can we say? Well, if it factorises like this, that can only be the case as long as the equation being x squared plus ax plus b must be equivalent to x squared minus open brackets a plus b close brackets times by x plus ab. Now, in order for that to be the case, you need two more equations to prove that. So, first things first, let's label this equation 1. So if we move this over to the side, obviously not that far over, if we can move it back a little bit, then we can put a 1 there and say that's equation 1. Now, as I said, in order for equation 1 to be true, you have to have two more equations which prove it. So, the second equation, of course, would be a is equal to minus open brackets a plus b close brackets. Move that over the side and then slap a 2 on it. There you go. Again, for 3, you've got b equals ab. Now this is slightly more simple, which is useful because we'll be using this one specifically in a second. Okay, move it over to the side, slap a 3 on it. Brilliant. Now, what can we do? Well, let's have a look at equation 3, like I said. So you've got two terms, a and b. Okay, if that's the case, then let's have a look at a. What's the possible values for a? Well, in order for any number, but we're using b for this, in order for b to be equal to a times b, then we need to think of a number which, when you times that number to any other number, the original number is still the case. For example, say you have, say b was 7 for argument's sake. 7 times something would still have to be equal to 7. What does this mean? I didn't mean to bang the table, sorry. So what does this mean? Well, it would mean that a would have to be 1, right? Because that's the only possible value a can take, because any number times by 1 is still that number. So we know a is 1, and of course we know b is 0. Now, why do we know b is 0? Well, because the only solution of what a number being equal to a number times itself. So let's have a think of this. We can't have 1 for this, because say b was 1 and a was 7. Well, then b does not equal 7 times 1, which is because b does not equal 7, because 1 does not equal 7. What number times by any number is still the original number? The only value for that is 0, therefore b must be 0. Therefore, we've got two possible solutions to these equations. When I say solutions, I mean different values of a and b, not the actual solutions which I mentioned here. Therefore, of course, if we move this up here, because it's not that we're running out of space, more or less, it's just because I like doing these animations in PowerPoint, because, well, they're a lot of fun, aren't they? And I'm sure you enjoy them. Right, so what can we do now? Well, let's have a look at the first case where a is equal to 1. Let's plug a is equal to 1 into this second equation. So if a is equal to 1, then 1 would be equal to minus 1 plus some value. Therefore, in order for that to be the case, it would be at least minus 1. Therefore, a is not equal to minus 1. 1 is not equal to minus 1. You'd need some number to add on to that, which of course would be minus 2. Because if you think of it, 1 plus minus 2 is 1 minus 2, or minus 1. Now, minus 1 is just 1, and of course a is 1. Therefore, this is our first solution, and this solution is valid. So we know we have at least one valid solution for a and b. Okay, well, let's take our second scenario where b is 0. If b is 0 and we sub this in, then this would be 0 here, right? Okay, well, let's think of a number. So that means if this is 0, we can just, I don't know why I keep getting that, we can just get a is equal to minus a, because we can scribble out the bracket and say a is equal to minus a. Now, what number is equal to the negative version of itself? 1 is not equal to minus 1, 2 is not equal to minus 2. The only number which is equal to itself in a negative form is of course 0, because 0 does not have a negative form. You can argue between if 0 is positive or 0 is negative, but crucially 0 does not have both positive and negative forms, meaning that if you do 0 minus 0, that's still 0, such as if you were to do 0 is equal to minus 0, that would still be 0, therefore a would also have to be 0. Well, if that's the case, crucially in the question, remember, it said a and b are different, therefore we can completely disregard this one and say there's only one solution, that being a is equal to 0 and b is equal to minus 2. Therefore, there's only one solution. So if we go back to the original question, of course it says a and b are different, so we know there's only one. So how many such equations are there? Well, there's only one, therefore the answer is B. Thank you so much for watching. I really hope you enjoyed this video. I really enjoyed making this video. I've not got many videos left in the Rising Star Maths YouTuber challenge, but I will still be making maths videos after this, of course. Now, as I always say, like and subscribe. Any suggestions, tell me in the comments. That's really all I've got to say, so thank you so much for watching. Bye.